Hello! Today the topic is basically how do we get a whole bunch of different, well, maybe not a whole bunch, but how do we get different meshes and textures going together in this scene. I'll just open up this folder here. Where are we? Now I've added an extra image. I've got a cat and also a floor image. So the goal is to get the floor basically on the ground, if that makes sense. Yeah, that's what we'll be going for. So we'll just open up the source folder and I'll make a new file. I'm going to call this definitions. And I'm going to write, this is sort of like a bridging header in Metal. I'm just going to write a few common definitions which the scene and the renderer will both need to understand. So first of all, I'm going to have an enum to describe the various types of objects we can have. Actually, we can probably just call that... No, I won't do that. Change my mind. There we go. Okay. And finally, I'm going to put together an object which will describe all of the renderable data, all the data which the renderer will need to produce the scene. So we're going to have a view transform, a set of model transforms, and I'm also going to need to specify a set of object counts. So I want this to be a dictionary. I want the keys to be each of the fields of this enum. Now, the way we can do this is if we just sort of scope this. So we say, okay, this is going to be, the keys are going to be objects in the object types, and the value types are going to be numbers, because we're going to be specifying basically for each object how many of these things do we want to draw. The procedure is we're going to draw all of the triangles and then we'll draw all of the quads. So with that in mind, I'm just going to head back to model and see this triangle file. I'm going to make a new one called quad, which will basically be the triangle file, but very, very much simplified. So we do not need to do any conversions. We're not going to do any rotations. I'm going to call this the quad class. We don't need Eulers, so we can get rid of that. And we probably don't need to do anything in the update function, but let's go ahead and keep that as it is anyway. We might want to in future. So yeah, we're just stripping this back, making it very simple. The quad just has a position. It doesn't have any rotation at all. That's fine. So we can close that down, and we can close definitions as well, and we can go to the scene. So of course we're going to need to import that quad class, and I'm also going to import the common definitions. That is the object types and that render data object. Okay, so we'll just start here. We'll have the triangles, and as well as that we'll have a set of quads. I mean, a lot of this session is pretty straightforward. There's a few tricks, but otherwise it is what you'd imagine. I'm going to have a quad count, and then I'm going to split this out. So this part here is basically making triangles. I'll just grab that and make a function for it. Def. I'm thinking of Python. Okay, so that's all well and good. We'll just go up here and we'll say, okay, make the triangles. Technically, we probably don't need a variable here because we can query the length of these on the fly, but why not? Okay, so down below, we will go ahead and make the quads. And we'll just call that function as well. So I'll say this, make quads. Okay, that's all good. So there's a bit of a trick here. And if the trick is, if we look down here, we are writing the model transforms for the triangles and the quads into the same array. No problem, we can totally do that. But it's a good idea to initialize the I position at the triangle count to make sure that those model matrices are being written after the model matrices for the triangles, if that makes sense. Alrighty, so we'll go for so yeah, as you can see, it's very much what you would expect. Oh, I just realized I missed something. If we go back to quad, in the constructor, we no longer need theta. There we go. Okay. So we create it at that XY position, height of 0. And we go ahead, write that in. Just don't forget to increment the quad count, not the triangle count. Okay. Yeah, that looks good. Then we can go down, just quickly double checking. Yes, that does look good. Okay, now I just realized this should probably be less than or equal to, otherwise these will be lopsided lines, not that it matters. Yep, happy with all of that. Okay, so we go to the update. Now see, we have this variable I, so that's fine. We can keep the common variable because this is all happening in the same function. So we can go do the for each loop on our quads. So we go ahead, we update that, get its model, and write that in. Perfect. Okay. Now I just noticed something else. When I was making this, I realized that the camera look is a little bit inverted. So I'm just going to flip that around, and that should make the mouse look feel a little more natural. But yeah, that's looking fine. Now I'm going to go to this get triangles function. I'm going to call it get renderables. And I want this to return, not there. I want this to return that render data object. So let's jump in here. Okay, so we need for the view transform. So we'll grab that. Then for the model transforms, we can just send in our object data. And then we have the object counts. Again, that's a dictionary. Now, if we hover over here, it says we need to provide two keys. We need to provide key 0 and key 1. And those are indexed by the field. So if we go object types triangle and hover over there, it says, yep, that's a constant 0. So associated to that, we'll have this triangle count. And then again, if we hover over here, it says, okay, all good, but we need property 1. Okay, no problem. So I'll go ahead and set that. Okay, so that should be working. We can close that down for now. I'm happy with that. Okay, now I'm going to head over to the view side. So I'll just grab this triangle mesh, and we might be saying, hey, it's a little bit cumbersome to have a different class for each type of for each type of mesh, and I would agree with you, it totally is cumbersome. What we will do in future is load models, and in that case we can just have the one class, just a general mesh class, but for now it's still being done this way. It is what it is. Okay, so we'll have this quad mesh class, and very little has to change here. I'm happy with this. I'm happy with the layout. We are still using the same vertex format. It's literally just that we have a different data set. So I'm going to paste this over. Okay, if we check through here, this is spanning a width and a height of 0.5 in the X and Y, and always at a height of 0. So yep, that is just going to have an area of 1 square meter and sit down on the floor. We have texture coordinates down here. Okay, so that is fine. We can close that down and go to the renderer. Now, things are going to have to change a little in the renderer. For one thing, we don't need any of that. And in future, it's going to get more elegant. Right now, we're just getting the thing working, so it's going to be a little ugly. That's fine. So we'll just import those definitions, so the object types and the render data. And I'm also going to import the quad mesh. Okay, so now if we look down here, let's have a look at these pipeline objects. So if we look at this bind group, let's go down to create pipeline. Okay, in the bind group, we have a bind group layout. That's fine, that can stay the same for all of them. That's just briefly describing the things that are going to go in there. But the bind group itself actually refers to real objects. So if we look here, this refers to a specific material. So then the question is, well, how do we draw a different texture? We bind a different bind group. So we're going to need a whole bunch of different things. One of them is we're going to need different bind groups. So I'm going to call this triangle bind group. That's what I said. It's a little bit ugly at the moment. We'll clean it up later, but this is acceptable for now. And then quad bind group. Okay. And then if we go down, we have triangle mesh. I'll do the same thing here. So I'll have triangle mesh and quad mesh. And then we'll have triangle material and quad material. Again, it's not perfect, but it works. Okay, excellent. So then we just go through and make everything. So we'll go down. I'm happy with that. Initialize. Yes. Setup device is fine. Depth buffer, that is fine. Okay, so this pipeline. So go down to the bind group and make the triangle bind group. That will be referring to the triangle materials view and sampler. And then we'll just grab all of that code and make it again. There we go. So we're making the quad bind group based on the quad materials view and sampler. Now, if you're curious, couldn't we make a dictionary and put the keys as the object types and automate a lot of this in a loop? We absolutely could. We absolutely should. However, because at the moment those meshes are in different classes, it's just, they should be in different classes. It's just a little awkward. And so I'm going to defer that for a future session. All right, so where were we? We've got make pipeline. Okay, create assets. Well, this should be pretty straightforward. We'll have triangle material, and then we'll finalize that or initialize that. And then we should also have quad mesh. Okay, and then we'll go ahead and we'll make the quad material. And then finalize that down below. I can't remember why I put this code down below. It really doesn't matter. And we'll put in floor.jpg. That was the one. Okay. So that should be fine. We can close that. And the final stage is this render function. So what I want to do is I want the render function to take an instance of that render data object. I call that renderables. And then we'll go ahead and use that. So here we can just go grab the renderables view transform. And then here, just make this a little neater. So we're just grabbing the model transforms. Okay, well that should be fine. So, yeah, that's fine. We set everything up. Okay, so it's down here. It is down here. So I'm just going to make a variable, because remember, we are passing a common buffer, storage buffer with all of the model transforms. So I want to keep track of where I'm up to in that buffer, basically. So first of all, we'll do the triangles. Yep, checking that. Yep, triangle mesh. That is fine. And then we'll set the triangle bind group. And then we'll go ahead and draw. So we'll have 3 vertices to get the number of vertices, to get the number of instances we want to draw. We'll look at the renderables, and then we'll look at the object counts, and we'll index into that with the triangle type. And then these last 2 arguments are the first vertex and the first instance. So for the first instance, I'll just set that to objects drawn, like that. And then I will increment objects drawn. Okay, so that's the triangles. I'll do all of that again for the quads. If you're wondering why I keep putting semicolons on the end, even though that's not the thing to do in JavaScript, I don't like JavaScript. I like semicolons. Okay. Let's double check all of that. Of course, this should be 6 vertices now for the quad. And that should be the quad mesh and the quad bind group. Okay, fingers crossed, that should be fine. So the last thing we need to do is just go to the app and make sure that we're sending the data over properly. So I'll just go here. I'll tell the scene that I want to get the renderables. And that should be fine. Okay, now really fingers crossed, so let's see how this goes. Well, that's not meant to be happening. Okay, let me just double check that. Oh, that's strange. That should be quad count. That doesn't quite explain why nothing's being drawn. Maybe it's being drawn from behind the camera. Anyway, let's try that again. There we go. Okay, so the issue was that when I was getting the renderable data, I was passing in the number of triangles, not the number of quads, and the loop to create the quads started from way back behind me, probably. So that's why I couldn't see them. It's only drawing a few. So also I noticed now that I can see the ground, I noticed that my camera can fly. So that's pretty cool. But yeah, here we have it. So we have different textures, different objects. It's very cool. You will notice that we're getting some aliasing issues with the texture. So probably the way to fix that is with MIP mapping, so that when the texture is further away from the player, it draws at a lower resolution, and that reduces the oversampling issue. And that'll actually improve performance as well. But yeah, for now, I'm pretty happy with that. So 2 things to look at in future, I guess MIP mapping is pretty important, and then loading object models or loading any sort of model so that we can, get things working. Anyway, that'll be it for now. Hope you had fun, and I'll see you again soon. Bye.